Yeah, just to take us through the kind of live demo part, I think we'll use, how we'll do that is we'll use the Glasgow IES HQ, as we have one of the IES live dashboards implemented here, and we use this daily as our kind of energy management system, if you will. So to kind of jump into it, I suppose, I mean, the first step is to bring any virtual environment model you may have up to a level where it becomes an operational energy model or a performance digital twin. So just as a kind of bit of background to that, any design or compliance models are a perfect place to begin with that. And a key piece is of your dashboard creation is this baseline in model in practice. Now, I'm going to assume that most on the call today are familiar with the VE software, and you will be aware that the VE is used throughout the world by architects, engineers, and by those in the construction sector to complete a range of different building design and analytics exercises, including meeting compliance requirements, HVAC size and daylighting, and CFD, for example. Now, the goal of this first exercise is to integrate as much operational data as possible within your VE model to override any assumptions that you've made at an earlier stage. And this can be used by, say, utility bill data or sub-meter data or operational profiles, whatever you may have, and ideally that would be also include that room level data, so including that small power kind of information that you can then populate your model. And this can all be done by maximizing the full potential of your virtual environment software. Now, this is also a really good way of using any site energy audit data that you've got. And this can include like conditional reports and observations. It could be really powerful for maximizing the actual impact that this survey information will have to produce tangible outcomes. By populating your model with this information, you can then start looking at the actual impact of how this has an impact on your site. And BMS data is a really useful resource here to assess your actual performance of how the building's performing against the design intent to integrate your findings. The kind of end result of all of this, kind of bringing the audit information into your model within the virtual environment, is that you now have this powerful tool to inform your future improvement scenarios and help de-risk your capital investment and potential upgrades. With this upgraded model, users can now use the Apache Energy Simulation Engine embedded in the software to basically stress test any future decision making with confidence and to monitor your building performance based on real world performance data, i.e. you're replacing those assumptions, that initial operational profile with the real data in the first instance. So what IES Live now does is it provides, on top of this operational twin practice, a platform for users to provide real-world operational carbon reduction implementation to end users who are actually in the building, kind of linking that operational digital twin with your building asset, if that makes sense. So a key next step in this process is connecting your building meter data from any source to the IES analytics platform, which then integrates with your virtual environment model. Now, that full piece on data connection, I'll omit today in full, but as a generally, any time series data from, say, building controllers or sensors, meters from building systems can be connected across different BMS or SCADA systems. We can also integrate just general AMR smart meters, sensors, anything you have. IES can fully support with your building connection exercise and have a host of experience in connecting different information sources to our platforms. So with the connections made to your IES analytics platform, these can now be fed into the dashboards alongside your digital twin information as well. So this here is what we've kind of shown in parts in the slides so far, but this is the IES Live dashboard that we've created. So this is the entry page. This is the first page that users would have access to, so they can assess their buildings effectively. And if you think of this can, BMSs obviously have a lot of data. This is like a focused energy platform to assess how your building's performing. So we have this overall energy consumption chart here, and this has got electricity and biomass kind of overlaid at the moment. And again, this is our IES HQ, if you will. We have a different view here. So this is the last 48 hours, but we can also, and I'll just refresh that, sorry. We can also, and if I just click here, also kind of assess that in different timescales, 30 days, for example. We also have these placards down the bottom looking at, like, say, total energy, for example, energy UI, carbon emissions, and actually cost as well. So we can start integrating cost into the dashboards to make sure you're on track for what you're trying to hit. This initial screen is kind of answering the first question of IES Live. How is my building performing now? It's an easy to read, easy to understand platform to say this is what it's doing at the moment. But even at the first step of this, you can see in these main placards, you can see this predicted energy underneath each of the total energy, total electricity, and total biomass. And the reason for that is it's that predicted nature. How are we on track to meet our targets? And as we go through this, you'll see there's more and more insights delivered by your digital twin. So the kind of next thing I'd just like to touch on is just this left-hand side here. This is the sensors part. So you've got ground floor here, and we've got our first floor. And if I drop down the hamburger menu here, you can see that I've got all of the rooms that we have at our building here kind of displayed. And if I click on each of these rooms, you can see that we have our temperature sensor, our humidity sensor, and a CO2 sensor in this space. You can also see in this floor plan that we have here that this is where that sensor is located. And if I click onto my expand button here, you can get a little bit more information about the general tracking of this exact the meeting room. Again, with the functionality of basic reporting, understanding what the average temperature over the last 30 days has been. Again, we can click around these sensors on the plan, and these floor plans are totally and fully editable, so to suit the exact location of where you are and what the actual building topography is. What I will also add, well, obviously you can click through all of these different rooms, but on the right-hand side here, you have this kind of either a kind of exclamation mark or a kind of tick. And what this is basically saying is a kind of indicator of if your room or space is in an acceptable bracket. So you set the CO2 temperature and humidity levels, and as soon as they go out, kind of emit from them, then they flag it here as an alert. Up the top here, you have this indoor environment quality performance metric. This is a summary of all of your spaces and all of the metrics to give a very quick, easy to read view of how each of the spaces are performing and how your building is performing as a general in terms of thermal comfort. Kind of moving on just ever so slightly, I'll then go on to just the kind of tabs up the top here. So we have the first one is quite a useful one, is this occupancy overlay on top of our electricity and biomass use. So what we're basically linking is how our occupancy and operational profiles are linked to each of the metrics or the energy use at our site. Again, broken down into the overall energy consumption, how much it is per occupant in terms of the occupancy at a time, and the cost per occupant that we've got. The next two tabs, we have a bit more breakdown of our electricity consumption. And now, beyond just basic data reporting, this is when we start to see the inputs from, say, our energy model feeding directly into our dashboard. So again, we have an electricity total, the EUI, the CO2, and the cost, but now you can start seeing this electricity meter graph. This is the total electricity, and this is a simulated. So are you on track, and is there any spikes above and beyond what you should be operating at? So it's a kind of baseline of what your performance should be at your building, and we can break that down by utility type. I'd also stress as well that this is obviously just one main electricity meter. You can break that down to sub-meter level, and you can have that as part of this view as well. The other two key delivery parts of the dashboard are this two sections. This bottom left here, this actionable intelligence. Again, this is where the digital twin and our dashboard meet the actual building. Each of these actionable intelligence points here are interventions for building users to have that have been identified in the model and updated live in the dashboards. You give a brief description of what the intervention is and why you want to do it, an idea of what the baseline and the proposed measures would actually impact when you've done it, what you need to do to consider to action it, and the estimated savings. And this one in particular is in tons of CO2 equivalent, but you can also make that into, say, cost, for example, and you can do that. And that these can be updated live for users to reflect or to review as they see fit, basically. And this is all of the inputs you've included into your energy model that you can now review and feed back to the end user to create actual change in the building from your building model. And probably the last point just to touch on is this actioned projects piece. Now just going back to our, say, survey results where we look at, say, retrofit, and we want to understand the impact of any changes that we have. This tab here is particularly important for tracking anything that you're proposing at your building. For example, if we are, say, and for the example we have here, we've updated our LED lighting in the description, very light touch, saying we're now going to be doing lighting replacement. What we can do is track the energy change of that measure live on site and feed that back into a model. Are we making the expected gains from that intervention? You can see that from, obviously, since this has been implemented, we've had a 16% reduction and a cost saving of this as well. Again, this adds further value to any decision making, again, quantifying any capital investments that you're making on site.